Hello, I'm Jibril, a seventh grader in Hawthorne, California from Al Islamic School, and this is Aziz, a sixth grader. Today we are presenting our science fair project which tested whether two objects of the same size but different weights fall at the same speed. Our hypothesis was sadly not supported. We discovered that the heavier object fell slightly faster than the lighter one. This happened because air resistance slowed the lighter object more. In a vacuum with no air, both objects would have fallen at exactly the same speed. The purpose of the science fair project is to test Newton's second law of motion and see if two objects with the same surface area and different masses will free fall with the same acceleration from different heights. Before we begin, we researched free fall, which is when an object falls due to gravity, which pulls everything down at 9.81 meters per second squared. In a vacuum, all objects fall at the same rate, no matter their size or weight. However, without a vacuum, air resistance affects lighter objects more, which is why the heavier objects seem to fall faster. Newton's second law explains the relationship between force, mass, and acceleration. When an object falls, gravity is the main force acting on it. In a vacuum, mass doesn't change how fast an object accelerates. But on Earth, air resistance slows lighter objects more because they are less dense and have the same surface area. It was hypothesized that if two objects with the same surface area and different masses are dropped from the same height, then because of Newton's second law of motion, they would free fall with the same acceleration. Our independent variable was the mass of the object dropped. The dependent variable was the object and acceleration at which the objects will fall from, and that they will be fall from at various heights. The control variables are the same location, the same heights the objects will be dropped from, and the same phone. The materials we used were a phone to record, a scale to weigh the objects, two books, 2 meter sticks, tape, a notebook, and pencil. The procedure was we used two books with the same surface area but different masses. One was at 500 grams and 72 grams. We marked each heights using meter sticks, recorded the time each object took to hit the ground, repeated each drop 5 times for each weight, and calculated the acceleration. The lighter book's average acceleration was 8.449 meters per second squared, which was a negative 14% of error. The heavier object fell at an average acceleration from 8.91 meters per second squared, which is a negative 9% of error. This graph compares how far each object fell over time and shows that heavier objects fell a little faster, likely because air resistance slowed the object more. This graph compares distance to time squared for both objects. The similar slopes of the lines shows that both objects experience similar acceleration, which supports Newton's second law. The lighter book's average acceleration was 8.449 meters per second squared, slightly less than Earth's 9.81 meters per second squared because the air resistance slowed it more. The heavier book's average acceleration was 8.91 meters per second squared, was still below 9.81 meters per second squared, but faster than the lighter book. This shows that the heavier object was less affected by air resistance.
In conclusion, our project shows that while Newton's second law holds true, air resistance affects lighter objects more. In a vacuum, both objects would fall at the same rate. This has real-world applications like skydiving and parachute design, and in space exploration. In the future, we would like to study how surface area affects air resistance. We would like to thank judges for listening to us, thank our school for this opportunity, and thank our amazing teacher for her guidance and this patience.